Hello and welcome back to the RET course lecture series on wind turbines. I'm Miro and we will start with the third lecture in the wind power series about history and development of wind turbines. We will concentrate first on the ancient and medieval history of windmills, and we'll go quickly through the most interesting points from those old times. Everything is believed to have started very, very long ago, thousands of years ago, in the Middle East, Central Asia and China. It is documented that such windmills, you've seen them already on other pictures, have existed. Built like solid structures, vertical axis windmills with stone or blades made of reed facing one prevailing wind direction. The whole rotor is partly covered by a solid wall, so that the free half of the rotor is actually experiencing the wind force and can rotate. The purpose of those devices was either milling of grain, of course, or pumping water. There were no other applications that the ancient human beings needed or demanded from windmills, other than bigger devices for military purposes. And the first travelers who had photo cameras in the old days, in the 19th century, actually managed to document some of those. Unfortunately, they don't exist anymore, but we do have some old photos remaining from Afghanistan. This photo is believed to have been taken of a typical ancient windmill, partly covered in a solid structure, and of course relying on a predominant wind passing through the whole structure. Of course, you see in this direction. It cannot work with a wind coming from the sides. A similar device that has been able to accept wind from all directions and whose purpose was mostly for pumping water, irrigation, has been documented in ancient China. And it was even more genius, managing actually to operate as a typical vertical axis windmill, where the rotor advancing towards the wind or the flat plate advancing towards the wind managed to rotate automatically and experience less drag force, while the flat plate advancing with the wind is flat, perpendicular, normal to the wind direction, and takes in or produces the largest drag force. Windmills came to Europe again mostly for both milling grain or irrigational purposes towards the Middle Ages. And it is believed that it happened approximately 100 years ago down at the Mediterranean coastline, and they were again very solid structures facing one predominant wind direction, not yet being able to yaw. Also, they were kind of a first stage or first step towards modern windmills by using multi-bladed sail-like blades. It is actually a cloth, a sail, stretched here in a multi-blade format, producing a rotational force now on a horizontal axis, properly facing the wind and rotating the rotor in a plane of rotation which is normal, perpendicular to the wind flow. They were the so-called tower mills, and they can still be found now only as museum structures down in southern Europe and North Africa. Later on, the windmills advanced into Central Europe and reached also the northern plains, England and so on, and started to be used quite a lot in places where there was no hydropower enough to run a grain mill, of course. In the Netherlands, they were also used for, well, the opposite of irrigation, you can guess, for dewatering of the plains. And windmills also improved to a certain extent, so they were now resting on a pole, on a post, being in this way able to yaw. So you could rotate the whole machine and follow the wind as it changes direction, thus being able to operate all the time when there is wind. the four-bladed structure became the governing one for the typical European windmill. Windmills started to get produced in all sizes and dimensions. The next improvement was a kind of mechanical device allowing the miller to actually yaw easily the whole structure around to properly face the wind. This could easily be done by hand, thanks to the long lever here, or by an animal. Even if used for irrigation or for dewatering of lands, windmills could be very, very small. Now this is an Archimedes pump here, really nice example. Doesn't matter how you yaw it, it always has access to the pond, to water, and then it pumps it out into a channel that is not visible here. The point is that yawing is very possible, but it has to be done by hand. It has to be fully controlled by hand. The first scientific approach, quite an interesting moment in the middle of the 18th century, is believed to have been done by John Smeaton, a famous British, English at that time, researcher, physicist, and alchemist, who actually produced a very genius apparatus. Now, the typical windmill to be tested, just the rotor of course, is resting on a lever counterbalanced by a weight just to stay horizontal. Everything is attached to a vertical axis, which with a rope here, small rope pulled by hand, is possible to be rotated. Now this whole structure starts to rotate in a horizontal plane, thus creating a kind of a wind. It's not really a wind tunnel for testing here, but simply this, while being rotated, it creates wind. The rotor starts to perform by simply creating a thrust, a certain torque, and pulling this weight here, which now we can measure what kind of a torque or how much force the rotor would produce. John Smeaton managed to prove that in his own way, the four-bladed rotor was superior. He tested different rotor arrangements, different number of blades, and most of all, he tested different twist angles for the blades. And he defined the proper or the best twist for the wing. Still, those old windmills, they were not rotating very fast. So you can't really see so clearly the twist of the wing, of the blade, as it is seen in modern long-bladed windmills. But if you look carefully, you would still easily notice that the blade is twisted. And those guys in the old days managed actually to build this and to find the best twist angle simply by experiments, empirically, without any theoretical background. Windmills grew enormously in sizes. In the Netherlands, you can still see all those enormous structures where actually the family of the miller is housed in it. It could even be made out of stone with a wooden cap that actually holds the whole rotor, or it could be made out of wood, an enormous structure out of wood, as big as a modern several-story building. The blades as long as like 10 up to even 20 meters rotor diameter. All the operation was still manual. The yawing, of course, either with the help of animals or several people just rotating the whole cap around. The blade start and stop procedures, everything was done manually. And then we come to the first real invention, the first mechanical implementation that improved or allowed for the windmills to be taking the next step towards modern machines. And that was the fantail, simply. Whether lying close to the ground, really on the pole, on the lever that helps with yawing, or, like here also, or up on the cap, close to the, or just behind the wind rotor. The fantail helps in a much better way compared to a flapping tail, a simple tail vane, to rotate automatically or yaw the rotor towards the wind. It is a simple rosette or a small rotor, just looking in the same way, usually multi-bladed. It is supposed to deliver a large torque with a very, very small speed. It's not supposed to rotate fast. And as soon as the rotor is slightly askew to the wind, the fan tail will actually experience some kind of wind, will pass through it. It will develop the torque in a proper direction so that to rotate the whole windmill towards the wind. You can still see the fan tail used instead of a tail vane in, let's say, a bit more modern machines, simply because it's much more smoother and safer compared to the typical flapping tail vane, even if we do need actually to implement here a mechanical device, kind of a gear that is connecting this small tail, fan tail towards the yawing ring. And we do need a yaw ring, of course, where the whole rotor is resting on bearings so that it is able to rotate and face the wind. The large wooden structures of the typical medieval windmills were really interesting inside and very difficult to build, everything done by hand, of course. The typical structure would be like this. You can find it in books. Everything made out of wood. Wooden axes, wooden blades. They were just wooden lattice structures, either covered with cloth, sail, or with wooden flaps, so that to create really the flat surface, properly tapered and twisted to deliver the torque. The gear would look like this, just like wooden kegs attached to a pinion would actually deliver or convert now the rotational force here into will give it to a rotational vertical axis, which in turn would rotate one or several milling stones here. This is just an example of a bearing, cast iron made, smeared with any fat you can find. Everything else is wood. The power output control, of course, was a tedious job to do. Not only that the cap was manually rotated to face the wind or to yaw the turbine, but whenever you have to maintain the whole machine or the blades, and not even maintain, but just, for example, to do some power regulation in very strong winds, or to start up the machine in very low winds, you have to climb up the blades and uncover the cloth or untap the flaps and so on. Later on, people managed, now what you see here is not really visible, to implement new improvements in terms of the blinder style of a blade. Here, the flaps actually are turned so that it's almost like a staircase. While you see here another lever shown, part of it is visible, which can actually flap back to like a real blinder, all those small pieces, and in such way uncover the blade, or the rotor actually changes its solidity, so the power regulation can be done. Still, it wasn't automatic. You have to stop the machine and attend to each blade one by one until it's ready now again to be set into motion. To summarize the old and medieval history, we have to mention once again that windmills are nothing new. They have appeared long ago. Wind has been used not only for translational motion like sailing, but also for industrial applications like milling grain or pumping water. And those old machines were probably the largest possible machines that humans would be able to build apart from anything for military purposes. In the Middle Ages, windmills continued to grow in size and complexity they became the largest ever machines that we can find now if we look back into history, and pretty modern for the old days. It was very difficult to run and operate those machines, but looking carefully into their construction and the solutions for their construction and operation, actually we will find that most of those very early solutions can be traced all the way into modern ages and modern wind turbines. Thank you.